Well, I figured if I'm going to try to use my bending die to bend the upper control arm there across that one section, it's about a total of 4.5–5 inches of metal. I needed to reinforce this just a little bit. So this is just scrap. I milled a relief in there because I didn't feel like grinding down the welds right there, but it looks symmetrical. It was the piece cut out of the center here that I just lopped off at 2 inches, and you know, yeah, you can't see what I'm talking about. The other arm plate is sitting there. So anyway, I'll tack it into position here and do a little welding. Cool. Ton of stick out there, so part of the reason for the weird sound. Turn the speed up there a little bit, see what it does. Yeah, it's a little nicer. I could probably stand turn it up a hair more, but I don't really need to, all the force is going to be coming up, so it's not like I really need to weld all that. So, I can turn back down a little bit now. Ah, the tip's hot. Wow, that was weird. That ought to be close enough. Notice most things in the shop tend to be close enough. Alright, just a scrap piece of 3/8 there. I've welded the gussets on. Everything's cooled down. So basically I'm just bending one for a test and figured what the heck. That's the 20-ton press, and as you can tell, it's pretty close to the top end. Where are we sitting here? Oh, we're almost to 90. I'm not sure it quite. Yeah, it didn't quite make 90. But that's a That takes a lot of force. Anyway, I was looking too, you know, I got a much cleaner mark in here because I ground a round onto the end here and got rid of some of the dents. So a little nicer here too. So it ought to work okay. Let's see if we can bend the arm, hopefully. Push come to shove, I'll have to bend it in two steps. All right. Here's where the rubber meets the road. We'll find out whether or not the 20-ton press has enough grunt. If not, basically what I need to do is to make another bottom die that is got at least a 3/8 spread. Not a 3/8, a 3-inch spread, and possibly try it again. But, you know, hey, I've got it lined up. I've got it offset a little bit that way because the metal's thicker on this side than this side, so I want a little bit more of the pressure to be here, you know. I think that side will bend easier, so if it bends at all. This is 4.5 inches. I remeasured it. It's 4.5 inches of metal. I'm really hoping it doesn't distort the ball joint mount. Wow, getting close. Kind of strange though, it's not bending right where the die is though. Looks like it's bending along the weak spot of the curve there, but we just got a little more, so yeah, not much at all. Well, I don't know how much it's going to spring back. Let's see. Yeah, the bend might have sprung back just a little bit, but now granted, it's kind of hard to tell. Let's see here. Yeah, it is underbent a little. And it did that other problem. Well, I'll show you in a bit. Okay, so what I was talking about was, hopefully it'll show up in the video. We'll see here. You can see that the, can you see that actually? See the, this channel right here, okay? That's where, from there to there, that is where the metal flexed enough and the mill scale popped off, okay? So that is basically the true that's where the true valley of the bend is, okay? Even though you can see that this is where my mark was, okay? So what that means is it bent at the wrong angle, and so this thing is locked up even though I've got the nuts loose, okay? So when I take this thing out, they're gonna tweak and have to be massaged back into place. For what I'm doing, I just got to get them twisted back enough that this will rotate so that when I put it on the frame, I can go through the range of motion. It's not like they have to work perfectly. So you can just make that out. See, this metal's thinner, so it didn't get offset quite as much. Okay, but it still did get offset. Now, let's see here. That stayed fairly flat across there. And it stayed flat through there up until where the mill scale. So the bend starts, you know, basically right here in the range where the mill scale starts breaking loose. Otherwise, it's pretty flat to that point. And there is a little bit of that bend back in there. And it did leave, a pretty good mark in the bottom side, except for over here. So, you know, have to play with it a bit more. It might be the kind of thing where I need to, bend it in a different die. Or the other option is get out the oxyacetylene torch and give that a nice warm it up a bit, basically, and then bend it. And I think when I do that, I might have to have this is air bending because it's not actually getting pressed hard between the two dies for its shape. I don't remember what the other kind of bending was called, but I might have to make a die that fits the shape exactly. Or I might just have to pay the company laser cutting them to bend the ones I need bent. But anyway, angle-wise, let's see here. Let's see if we can get that worked around. I'm a little shy on angle there, as you can see. But what I'm going to do is, rather than I can bend it some more. So I'm going to go ahead and test it on the frame and stuff like that now, instead of and see how close it is. If I need to bend it more, I'll bend it more. That'll be easier than trying to straighten it out. All right, so in doing the bending, now that I've got it apart and I'm looking at it here, it popped the spot weld off the bracket here, and the way it popped it off, it's pretty apparent I did not get any penetration whatsoever into that with that tack weld. Tack weld doesn't really have to hold a whole lot usually, but would have been nice if it would have held for that. Yeah, it looks like the other one's held. Anyway, I did have to work it off, and let's see if we can get this in some kind of angle here. Alright, the one on the right seems fairly flat. The one on the left is off just a hair. But they were tight, so they'll have to get tweaked a little bit. Now, that weighs one thing. They're tweaked this way as well. I don't know if you can see the gap there. So they tweaked that way more than the other way. So that's where all the twist is. So basically, and I'm not surprised there because the angle here is different. So this one is tweaked in this way. This one's tweaked in this way. Right? Yep. Yeah, they're tweaked to the inside. So basically I have to take and twist these out a little bit. So I'll probably put it in the vise and just massage that around a little bit, trying to get that going. And then when I can get it slipped back together good, I'll pop another tack weld on there and put it on the frame. Alright, I got a 15-inch crescent wrench here. And basically what I've done is I've gotten it pretty close. I'm taking my ruler and going right here at the peak, and I'm really close. I'm getting rid of about half of it, but basically what I'm doing is I'm putting it up here, and it's hard to get the vise not to swivel, and giving it a couple of yanks and tweaks there and that stuff. Now, I don't really want to do it over here, because what's going to happen is this is the thinnest part, and the metal here is thinner than here, and I don't want to bend around this axis. I want to bend it over here, because I want to keep this fairly flat for the ball joint. But this is prototyping and testing, and the more important thing is that I'm able to check this angle with the ball joint. So if it doesn't mount perfectly flat, that's okay. But anyway, and actually what I've decided to do is, instead of wrestling it, I'm so close now that what I'm going to do is I'm going to cut these spot welds, because I got to re-spot weld that one anyway. So I'm going to put it back together. I'm going to cut the tacks and re-tack it back into position. And then that way, instead of having to sit here and try to tweak and bend and fight this, I can get rid of that and get everything back lined up again and move on instead of having to fight it. Okay, after I did that bending, rather than cut them off and re-tack them, it turned out that I could move it on the arm easy enough. I got them close enough. So I decided, I'm just going to go ahead and mount them up and see how close they are. Now, I'm sitting on this this bump stop. I had it in the rear, And you're probably not at the right angle there, but that's really, really friggin' close. Oh. Yeah, so it's a 1/2 inch off there. If I put this bump stop in, it just touches. Yeah, and if that bump stop squished at all, it would be bottoming out the ball joint. The ball joint's really close to its end there. So then what I tried was put the bump stop over there. It's on the bump stop, and we're 5/8 of an inch up. So it might squish that 5/8 of an inch, but not 5/8. It might squish it 1/8 of an inch, bottom out the ball joint, but I don't know if that's really an issue or not. So let's throw a gusset on here, and I think this is the right gusset. I hope it's the right gusset. One side clears. Maybe not. Anyway, I'll get the gussets on here in a minute. But what I wanted to show is I'm hitting the bump stop there, and I come all the way up, and I hit the bump stop down here. And if I remember right, that bump stop is cut for the full squish, and we're not anywhere close to. I shouldn't say we're not anywhere close. We're still within the ball joint range. If I were to take that bump stop off, then I could tell. So I may do that. Okay, I took a tape and measured at the spindle to ground basically, and with the gusset, or with the arm down on the bump stop, it's a 1/2 inch lower than it is now. Okay, so that gets about a 1/2 inch. Keep in mind too, with another bump stop over here, that one may not touch when this one touches, but that's going to be a secondary cushion kind of thing. You know, if this one hits first and squishes, then this one will kick in too. And I don't think that's going to be enough to, you know, really twist or flex that, but feel free to chime in if you disagree. So what I also did too was I took the bump stop out, and the spindle drops another 1/2 inch beyond. The spindle drops another 1/2 inch out here with the bump stop gone, and that's when the ball joint binds up. So that tells me that I've got 1 inch from where I'm sitting right now of suspension travel before the ball joint bottoms out. Perfect. Okay. When coming up, with the bump stop in place, okay, and I don't know if you can really tell here. You know, we're 1 inch above that rod there. Take it out, it comes up almost another inch, and I measured this as well, and it is almost exactly 1 inch difference. So that means that, you know, this is a cutoff bump stop, which is, you know, more or less approximating full squish. Okay, I have another inch of travel at the spindle past that before the ball joint binds, because that's what's happening right here. Ball joint's binding. I'm not hitting the frame or anything. It is the ball joint, upper ball joint binding. So basically the angle I have this at, remember it was a little bit short. I don't need to bend it anymore. For where I'm sitting with the bump stops, the gussets, everything like that, that angle is perfect. Perfect. It puts me right smack dab in the middle of the ball joint range. So I'm extremely happy with that. The next thing I need to do is go ahead and put the hub on and the brake rotor and that stuff, and check caster and camber with the arm on this side. And depending on how I like that depends on whether or not that arm is pretty much finished, or whether or not I got to make some tweaks. All right, this will be it for the day. I wanted to get an idea of caster and camber, so my lug nuts are in here just tight enough to keep this thing at ride height. Okay, in case there's any discrepancy, I didn't want it pulling one way or the other like I had a challenge with once before. So anyway, I did the Alt-0 on the center of the frame, and according to the wheel mount surface, we're at 89.2 2.3. Okay. Measured on the caliper mounting thing, which should be perfectly perpendicular to the spindle. It measures 89 degrees. What that's telling me is that I'm 1 degree leaning out. You know, which isn't catastrophic, anything like that. I'd just as soon have half a degree or 0, maybe even just a hair in. But a lot of stock vehicles, you ever look at a Ford twin I-beam suspension, they lean out bad. You know, so 1 degree certainly within the ballpark. What I might do is I might just go ahead and shorten that upper control arm up like a 1/16 of an inch. Because I did put a 3rd washer in the backside there, because I was further out than a degree. So I put 1 washer in. Instead of putting 2 in, I could go ahead and shorten that a 1/16 of an inch. That would still leave me some room on the other side to take a spacer or 2 out, and that ought to work just fine. So I need to run it through the range of motion and that stuff, but I'm tired and I'm late for bed. I got to work tonight. So I also checked the caster, and after I remembered to pull it forward and check it, it's sitting at almost right around 6 degrees. So we're about the same on both sides. So I'm pretty pleased to see that. And that's it for today. I'm real pleased with the bent one. The issues with the bend, I mean, I could bend them myself. That just might be the ticket, but I got to find a slightly better way to bend it. I'm not sure I quite have the tonnage, so I may just, you know, the reality is my set's going to be stock, both sets. One other set, going to Australia, is going to be stock ride height. So I may just bend them myself after they're cut and do whatever tweaking I need to do, because that will be a whole lot cheaper than trying to pay them to bend 1 or 2 of these darn sets. So, okay, guys, that's it. Yeah, as far as the prototyping goes, it's getting really freaking close to proof of concept being proven and done. Now it's, you know, finalizing CAD work and the bottom control arm and stuff like that. You know, I still got to deal with the shock mount now that I have the arm basically final design, all that kind of crap. So I still got to do the gussets for inside the arm and that stuff. So still got a long way to go. Got a lot of work to do, but I'm almost kind of feel like I'm over the hump. This design has been proven. It fits, it works on both sides, with the bend, without the bend. Yeah, so the tube arm is scrap. I do want to see if I can take this design and run it through the CAD program on stress analysis. So if anybody's got any clue how much load, you know, tons, pounds, whatever it takes on here, send it to me. Otherwise, I'm going to have to do some research and guess. Now, here's the thing, is there's a company out there that does 1/2 inch, okay, upper control arms, basically look just like this without the gusset, but they're doing it on full-size trucks, you know, bagged suspension, stuff like that. So if they're just butt welded up against here kind of thing, you know. And so my thought is, you know, 3/8 for a truck, half the weight, is overkill. So I'm really not too worried about it strength-wise, especially putting the gussets in here. The only possible thing is it might bend, you know, in here, but, you know, it took 20 tons to get that. So barring a wreck, I don't see it being an issue. And in a wreck, tough. Oh well.